Hi, I am Hams. You are watching my YouTube channel. Introduction to Electricity and the Dangers of Live Wires. Electricity is one of the most powerful forces in nature, yet it is invisible and often underestimated. Every day, we rely on electricity to power our homes, devices, and industries, but its misuse or careless handling can lead to severe injuries or even death. Understanding what happens when we touch a live wire is crucial for safety, especially for students, electricians, and the general public. A live wire, in electrical terminology, refers to a conductor that carries voltage relative to the ground. In a standard household, this is the wire that supplies power from the main source to your devices. When this wire is exposed and touched by a human body, the electricity seeks a path to the ground. Since the human body contains water and electrolytes, it acts as a conductor, allowing the current to flow through vital organs, muscles, and the nervous system. The danger of touching a live wire depends on several factors, including the voltage of the wire, the duration of contact, the path the current takes through the body, and the body's resistance. While low voltages may only cause tingling sensations, higher voltages can be deadly. Millions of accidents worldwide occur every year due to accidental contact with live electrical wires, highlighting the importance of understanding how electricity interacts with the human body. How electric current affects the human body. To understand the consequences of touching a live wire, it is essential to understand how electric current interacts with human physiology. The human body is composed of tissues that contain water, electrolytes, and ions, all of which make the body a good conductor of electricity. When electrical current enters the body, it flows along the path of least resistance. Typically, this is from the point of contact, through muscles and organs, and out to the ground through the feet or another grounding point. The effects of electric current on the body vary depending on the amount of current, measured in amperes, not just the voltage. Even a small current of 1 milliampere can produce a mild tingling sensation. Currents between 5 and 20 milliamperes can cause involuntary muscle contractions, making it difficult or impossible to release the wire. At 50 milliamperes, breathing can become impaired, and the risk of cardiac arrhythmia begins. Currents of 100 milliamperes or more are often fatal, as they can cause cardiac arrest, severe burns, and permanent nerve damage. Several factors determine the severity of an electric shock. Voltage. Higher voltages force more current through the body, increasing the risk of severe injury. Body resistance. Dry skin has higher resistance, reducing the current flow slightly. Wet skin or sweat drastically lowers resistance, making electric shocks more dangerous. Pathway. If the current passes through the heart or brain, the risk of fatality increases. Duration of contact. The longer a person remains in contact with the live wire, the more damage the current can cause. Real-world examples highlight these dangers. For instance, people who touch exposed wires while standing barefoot on concrete floors or wet surfaces are at a higher risk of severe injury because the body provides a direct path to the ground. Similarly, electricians working without proper gloves, shoes, or safety equipment often experience muscle contractions, burns, and in tragic cases, death. Types of electric shocks and their symptoms. Electric shocks are not all the same. Their effects depend on the current intensity, voltage, duration of contact, and the path electricity takes through the body. Understanding the types of shocks can help in recognizing the danger early and responding safely. Tingling shock. Below 5 milliamperes, the lowest level of electric shock is often called a tingling or perception shock. It usually occurs with low voltage contact, such as a small exposed wire or a faulty appliance. The person may feel a slight prickling or buzzing sensation in the hand or finger. While generally harmless, It serves as a warning that the electrical system is unsafe. Muscle contraction shock, 5 to 20 milliamperes. When the current increases, involuntary muscle contractions occur. This is known as the let-go threshold. At this stage, the person may find it difficult to release the live wire due to strong contractions in the hand muscles. Prolonged contact can worsen the situation, as the body cannot break free from the circuit on its own. Respiratory impairment shock, 20 to 50 milliamperes. Currents in this range can interfere with the muscles involved in breathing. Victims may struggle to inhale or exhale, leading to shortness of breath or suffocation if immediate help is not available. Cardiac arrhythmia and fibrillation, 50 to 100 milliamperes. At higher currents, electricity can disturb the normal electrical signals in the heart. Ventricular fibrillation can occur, causing the heart to stop pumping blood effectively. Immediate CPR and medical attention are required. Without it, death is likely. Severe burns and tissue damage, 100 milliamperes. And plus extremely high currents can cause serious thermal burns at the points of contact. Internal organs, muscles, and nerves may be permanently damaged. In many cases, the burn wounds themselves can be fatal if they are deep and extensive. Symptoms of electric shock, tingling or numbness, muscle stiffness or inability to release, difficulty breathing, chest pain or irregular heartbeat, burns on skin or entry or exit wounds, loss of consciousness. Recognizing these symptoms early can make the difference between life and death. Quick response, such as cutting off the power source and calling emergency services, is critical. Real-life cases of live wire accidents. Real-life examples make the dangers of touching live wires tangible. Accidents happen in homes, workplaces, and outdoor environments, often due to negligence, outdated wiring, or unsafe handling. Home electrical accidents. A common scenario involves someone trying to repair an appliance while it is plugged in. For example, a person touching the live terminal of a toaster while it is on can receive a shock that locks their hand to the device, potentially causing burns and cardiac arrhythmia. Construction site incidents. Workers in construction frequently face live wires during building renovations. One documented case involved a worker on scaffolding who accidentally contacted an overhead power line. The current passed through his hands and torso, resulting in severe burns and cardiac complications. Street and outdoor electrical hazards. Fallen wires after storms or accidents pose a serious threat. Many pedestrians or children who touch exposed wires receive shocks because the wire is energized, and the surrounding environment may be wet. Such incidents are common in areas with poor electrical infrastructure. Industrial accidents. Factories with high-voltage equipment often witness severe accidents when employees bypass safety protocols. For instance, one case reported an employee handling a live 440V circuit without protective gloves. The current caused immediate muscle contractions, knocking him unconscious, and severe burns required multiple surgeries. Lessons from real-life cases. Always assume a wire is live unless verified otherwise. Use proper insulation and protective equipment. Never attempt repairs without turning off the main power supply. Stay vigilant in wet environments, or where grounding is likely. Myths and misconceptions about live wires. Many people believe certain myths about electricity that increase the risk of accidents. Understanding and debunking these misconceptions is essential for safety. Myth 1. Low-voltage wires are safe to touch. Many think that a 110V or 220V wire cannot harm humans. While lower voltages may cause mild tingling, they can still be deadly under certain conditions, such as wet skin, barefoot contact, or prolonged exposure. Myth 2. Rubber shoes always protect against shocks. While rubber shoes provide insulation, they are not foolproof. Damaged soles, thin footwear, or standing on wet surfaces reduce their protective effect. Always combine footwear with proper gloves and equipment. Myth 3. Only adults get electrocuted. Children are at higher risk because their smaller bodies conduct current more easily, and they may not understand the dangers. Many tragic accidents occur at home when children touch exposed wires. Myth 4. Only high voltage is dangerous. Even household voltage can be lethal if conditions are wrong. It's not just voltage but current, resistance, path, and duration that determine severity. Myth 5. Electricity is visible. Electricity is invisible, and its silent nature often misleads people into thinking it is harmless. This invisible threat is why accidents occur, especially with hidden wires or faulty appliances. Advanced electrical concepts related to human safety. AC versus DC effects on human body. Alternating current, AC, changes direction periodically, while direct current, DC, flows in one direction. AC is more dangerous to humans because it can cause continuous muscle contractions, leading to lock-on effects. DC, while still dangerous, may push the victim away rather than causing sustained contraction. Electrical resistance of human body. Human skin provides natural resistance to current. Dry skin may have 1,000 to 100,000 ohms of resistance. Wet skin reduces this dramatically to 500 to 1,000 ohms, allowing more current to flow, which can be fatal. Current pathways in critical organs. Current passing through the chest or head is far more dangerous than current passing through a finger or toe. Pathways crossing the heart can cause fibrillation, while brain involvement may lead to neurological damage. High voltage versus low voltage safety measures. Low voltage, household gloves, insulated tools, careful handling. High voltage, industrial/overhead specialized PPE, isolation, grounding, warning systems. Transformers and electrical safety. Transformers step up or step down voltage. Incorrect handling of transformer terminals or exposure to high voltage lines is extremely dangerous. Even small mistakes can result in severe shock or electrocution. Detailed safety measures and precautions. Personal protective equipment, PPE, rubber gloves and boots, insulated tools, face shields and safety goggles for industrial work, safe handling practices, turn off main power before touching wires, verify live wires using testers, keep hands dry and avoid barefoot contact. Environmental precautions, avoid wet areas, maintain proper grounding in buildings, keep children away from exposed wiring. Emergency response, never touch a victim while they are still in contact with live wire.